Hello everyone, welcome to Potentiometer. Now, potentiometer is a device used to measure the EMF of the cell, the internal resistance of the cell, and potential difference between any 2 points or the terminal potential. Now, it is also called voltmeter of infinite resistance and is preferred over voltmeter to measure EMF of the cell. Now, for the voltmeter, here, it can detect and measure even the tiniest, sorry, not measure, but it can take into account even the tiniest amount of current. So when it does that, it actually measures the potential difference of the cell instead of the EMF. Whereas potentiometer, it has a very high resistance, higher than that of voltmeter, such that it can neglect and not even take into the account of the small current that is within the circuit. Thus, it measures the EMF of the cell and not the potential difference. Now here, we have wire A to B, and in general we actually have 10 segments like this: 1, 2, 3, 4, 5, and so on, and 10 segments, and each segment is of 1 meter. And here it is connected like this, and here this E dash is known as the driver cell, which sends the current, the constant current, throughout the wire A to B to make it into a potentiometer. And the wire A to B itself is of uniform cross-sectional area, again to make it into a potentiometer. And here this E is the external cell, which is connected to a galvanometer, and here a jockey is there to detect where the balancing length is, or where the null point of the galvanometer is. So this is of course used for the applications of potentiometer, which we will cover in the next few videos. Now let's talk about the principle of potentiometer. So here the principle is, if a constant current, so the current is constant, when a constant current is passed through a wire of uniform cross-sectional area, so here A is also a constant, then the potential difference across the wire is directly proportional to the balancing length. So V is directly proportional to L. And here in figure 2, we have just one segment of the potentiometer wire. This A to B is called potentiometer wire. And here let's say E dash is the driver cell, which gives current I. And we get, let's say a null point at point C with the balancing length L. Then according to the principle of potentiometer, the potential difference between A to C is directly proportional to the balancing length L. Now let's prove it. So first we can use V equals to IR thanks to Ohm's law, and here we have resistance. Now here resistance is directly proportional to the length and indirectly proportional to the cross-sectional area. And here we can introduce our constant, so this is equals to rho L by A, and here rho is known as the resistivity of the material of the wire, which is constant for all the materials, for the individual materials. So let's just put the value of R in this equation. So V equals to I rho L by A, but here I'll write by A like this and put a bracket over here. Why? Because according to the principle, the current is constant, the cross-sectional area is constant, and resistivity is of course a constant. So therefore V is directly proportional to the length. Hence we have proved the principle of potentiometer. Now as a note, I'll tell you how to increase the sensitivity of the potentiometer. So here we have K is equals to V by L. This K is known as the potential gradient, because potential is divided by length, thus it is potential gradient. And here you can increase the sensitivity of the potentiometer by decreasing the potential gradient. So that means here V by L, which is also equals to IR by L, right? V equals to IR. Now here what you can do is you can increase the length of the wire so that potential gradient can decrease, or you can decrease the current flowing through the potential wire. That therefore thus meaning that you can increase the resistance so that lower current can pass through it. So By decreasing the potential gradient, you can increase the sensitivity of the potentiometer. This is it for potentiometer today. I'll be covering the applications of potentiometer in the future videos as per our syllabus. And if you learned something new, please like and subscribe. Thank you.